Thank you, John, for reminding. All right. Yeah, thank you, Veena and Randhir. Yep. So, all right. Okay. So while joining A and B, if we use just the outer keyword, is that good enough? Is there some error in this syntax? Yes, Susant, I'll make sure that we make the previous sessions video recording available. Will not remove the previous sessions recording. Okay, let me just make a to-do in this. All right, all right. So is this correct or wrong? Anybody? Yes. We need to specify left, right, or full. That's right. Good, good. All right, good. Thank you. Sometimes we just have to take few records out of the full data set. In those cases, we can use limit. So we can say things like limit divs 10. Okay, it will give us the first 10 records. If you want more records, we could say limit divs some other number. All right. Now, the one of the things which is probably not there in the database is sample. Sometimes you want to take the small percentage of the data, small percentage of records from a big data, and you want to run your test cases on top of that. In those cases, the sample comes very handy. So when I say sample divs point 0.1, it means zero point 0.1 fraction of divs should be picked up from divs and should be kept in sum. So that is quite a useful command. It gives us the random records. Okay, it gives us the random sample, random 10 records. All right. So Randir's question was, will it be possible to join three data set? And that's what I was explaining. So I think it should be possible by saying join A by ID, B by ID, comma C by ID, or you can split the three data sets into this way. First join first two, then join the third one with the previous result. Okay, so that's what I was explaining when the connection got disconnected. All right. So Ganpati's question is, does sample gives record in random and limit gives first? Yes. Okay. And also in case of random, we do not say that we need these many records. Instead, we say this much fraction we need. All right. Now, question to all of you is, if we run this command, okay, let's say we are loading dataset and we are saying sum equals to sample divs point 0.1 and we run dump sum twice. Okay, so we run dump sum twice. Will it give the same output or different output? All right. Yes, it would give us different output. All right. It will give a different output because when you say dump, it is going to reevaluate everything and then use it. Okay. Yes, that's correct. All right. Now the strange part is, okay, okay. All right. Most likely no, but recent strategies in pig have changed a bit. So this answer to this question is basically had changed. Okay. So I think in the recent versions of pig, it's giving the same results when you say dump sum. Okay. But if you run the full script, like the way Veena is saying, if you run the full script again, then it gives the different results. But if you run dump sum twice, it's giving same results. That's something which has changed in recent versions because the sample is being computed here itself. Basically, the mapping, the random numbers are being computed while the sample command gets executed. Okay, so that is an irony of the situation, that this particular problem had changed in couple of last versions, right? So as of today, it is yes, both will have same output. Okay, in recent versions. Okay, so the strategy had changed a bit in the sense that for the sampling required, the random numbers required for sampling gets generated only once. Okay, and then the same random number are applied on the divs and you get the results. Okay. All right. Now there was few questions which I have skipped. One was from long back from Naveen. In ETL, we use update strategy. I need to understand more about update strategy, and I can definitely help you with this. Okay. So you can drop me in the email or put it on the forum, and I'll try my best to answer that question. All right. Then there is a question from Veena. When you say first, will it run the whole dataset and only display first 10, or will it run on first 10 record? Basically, it will not go through the whole dataset. It will basically go through the first 10 records. That's it. Okay. So in the map here, when we say limit, here it will utilize the first argument, which was byte count, that will be utilized here. Okay, so Sridhar is saying maybe Naveen was trying to say that how to update in pig. We don't update the data or alter the data in pig. All right. So Sridhar is saying, does limit give the same output twice? Yes. If you say after limit, if you say this dump twice, it will give the exact same output. All right. All right. Going ahead. So we earlier discussed that most of the number of reducers are decided by pig automatically, but and we also said that pigs are controllable animals, right? Keeping that philosophy intact, pig provides you a parallel keyword with which you can customize the number of reducers you want. Okay? Using parallel keywords, you basically control the number of reducers. It does not impact the mappers. It does not impact the map task. It only impacts the reduce tasks. Okay? Now, so when you are saying daily equals to load this file as these columns, okay, and we are saying group daily by symbol parallel 10, which means this grouping will be run via 10 reducers. Okay, there'll be 10 reducer tasks applied. So you can either apply parallel keyword per statement, or you could apply the parallel keyword in the whole script by saying set default parallel as 10. Then you don't have to keep on applying parallel 10 every time. Okay, now if you do not use the parallel keyword, by default, the way pig decides number of reducers is very straightforward. The strategy is that for each 1 gigabyte of input, it will create one reducer task. Okay, but if there are total number of reducers greater than 999, it doesn't go beyond 999. Okay, so it creates one reducer task per gigabyte. That's the default behavior. And in case your number of reducers are going beyond 999, it doesn't increase that. Okay, so basically, in the default strategy, the whole decision of creating number of reducer lies in the input data. That may also go wrong a lot of times. Imagine that you are using a map filter task, right? And in this filter, you are just removing almost everything. You're just keeping, say, hardly 1 gigabyte data, and the input data is say 100 terabyte. So unnecessarily, after the filter, we'll have only few key value pairs. Let's say we have only few key value pairs. But since the data input was 100 terabyte, it will end up creating 999 reducer, right? That is that's not great, because decision of number of reducers cannot be predicted just based on the input file, right? But pig cannot do much about it, because pig doesn't know how will your filter behave upfront, right? It wouldn't know the number of records that would result from your filter logic. Therefore, therefore, that's the only guess it has is based on the input file. It can't decide the number of reducers based on the intermediate data. Okay, because Hadoop need to be informed upfront about number of reducers. Therefore, it decides number of reducers based on the input data. Now, Vina's question is, by using the parallel keyword, can we go beyond 999? Yes. Okay. Yes, we can go beyond 999. Because when you specify parallel keyword, then the strategy of reducer decision is stopped. Internal decision making is stopped. And that internal decision making is what was limiting number of reducers to 999. Now, when you specify number of reducers by yourself, it believes that you are at your own and you know what you're doing. All right. Okay, Veena is saying, how do we decide on number of reducers while writing the script? You have to observe how much data are you generating, how much shuffling is going on in reducer, and also if you also know how many machines, what is the capability of your cluster, how many total number of reducer tasks can be run in your cluster. So that is first thing you need to know. Second you need to know is you need to observe, or you need to use your gut feeling that okay, my data is going to be equivalent, mm, my data is going to be quite huge, therefore let me just use these many reducers. Okay, so if whatever mapper data you are receiving, you're not doing much of a filtering, and you're right away doing the grouping, then you let pig decide number of reducer. But if you are doing a lot of logic and your data is getting minified by using filter, then in those cases you could decrease the number of reducers. So again, we go back to the same point as the beginning, that the number of reducers could go from 0.95 to 1.75 uh, times the total number of reduced tasks possible. And and this range, between this range is all your gut feeling and a bit of hit and trial. Okay, if you observe that your reduce phase is taking too much of time, then you go for bigger number of reducers. All right. Okay, again, same questions. How many reducers will it produce? Anybody quickly? Yes, first answer and I'll start. Yes, 0 reducer. That's good. Correct, Martin. All right. Now, another question. So, does parallel keyword has impact in this statement? That's correct. All right. So sometimes you have to call external functions. Okay. Why do you need to call external functions? First, the capability may not be there in pig. Okay, let's say there is a function which is there in Java, but there is no corresponding function in pig. In those cases, you could simply define the function in the following manner. You could say define hex, invoke for string, and you could say this. So if there is a static function, you can define it like this, and then you can use hex here, hex as if it's a built-in function. Okay, so if because converting integer to hexadecimal string is something which is not there in pig, but we want it. So if we want it, we can basically export this function, or define this function here and use it. Okay, so the syntax is whatever absolute what do you call fully qualified name of the class of the function we have to mention, and then the kind of data it accepts as argument, and then the return value. So invoke for string, has it been returning integer, we would say invoke for int. All right, so this is how we can we can call the Java built-in function. Okay, this is how we can call the Java built-in function. Now you can see here that we are calling this function here. All right, and sometimes you have your own Java function and your own Java class and you want to use that. It's very straightforward actually. All you have to do is put this acme.jar in the current folder in the local directory, not in HDFS, but in the local directory, the directory from where you started the pig command. You put your acme.jar in that folder and then say register acme.jar. Okay. And then you say convert, you say define, and you give the name of the new function which you want to define, and then the original class, this is the original class. Okay. And we are saying that it will, this is the name of the original class, and then we are giving the argument to the constructor of this class. Okay. We are giving the argument to the constructor of the class saying dollar to euro. All right. And then we can call this convert function like this. All right. I'll give you a couple of examples. So then you can call the convert function like this. All right. Now, in case you want to call a Python function, it's actually pretty straightforward. All you need to do is register your Python class using Jython and give it a name, and then you can call any function defined in that class, that file. So what is Python class generally? Python file is generally made up of either functions, classes, or code right away, expressions. So you can call the functions which are mentioned in a particular Python file. And the way, imagine that in this production.py there is a function called produce, and we are calling that function here. So what does it do? We are saying for each sum data set, generate name, comma, this. And what does it mean? It means we are executing produce function of production.py file on this particular value. Okay, so all we are trying to demonstrate it. Okay, so all we are trying to demonstrate is that you can call any external library very easily. So Venus question is, do we need to load any Java library for this? For this one, I don't think so, because Jython is by default installed. Okay, Jython is by default available for Pig in Pig, and then you can use right away. All right. Now let's try to give you a demo of creating a custom user defined function and then using it in our program. Okay. All right, here we go. So we have pig UDF like this. So in this you have, let's have a look at our function. So this is not pig UDF, yeah, pig UDF only. So we are defining a class called upper. So for every function which we want to create, what is it that we are trying to do? We are trying to create our own function which we can call while doing the projections. Whenever we are saying for each a generate something, we can use our functions. Okay, so to do that, we are defining a class called upper. So whatever function you are trying to call, we need to define the name of that class and then extend from eval function. Okay, eval function, and whatever return type you want to define, you define it here. You can see that the exec method is returning the same data type. Now you look at this function, what does it do? So every class you define eval function, you have to implement a method called exec, in which you will be given a tuple as input. Okay, and you have to do whatever you want to do over tuple. Okay, and then return. So what we are doing is we are saying in case the tuple is null or tuple has got 0 records, return null. Okay, in case in case if it is not null, get the 0th value. In case 0th value is not null, then only return the uppercase. Okay, so we could do anything what we want to do in this function. Okay, and once we are done with that, we basically export it as jar, just like the way we did for MapReduce. So we are saying here, we are saying sg dash pig udf dot jar. Okay, and now let's just copy it scp downloads sg dot pig udf dot jar onto s5665 at h2.cloudxlab.com. Whoa, sorry, it has to have the column. The All right, let me take the password, put it here. All right, now here we can now say register sg.pigudf.jar. It is successfully able to register. Okay, now we can do things. So let's say cat a does not exist, cat data a, it does not exist. All right, let's try to run our code on this particular file. All right, let's try to run it on this particular file. So what does it do? Or do we have xyza? Doesn't exist. Never mind. So yep, ls slash data. Do we have? All right, we'll just go with the slash data pig slash a. All right, slash a. Okay, then we are saying b equals to generate this and then dump b. Okay, so here what you need to know is that the we are basically calling it over only a single value. See, it got converted into uppercase. Sounds good to you? All right, there is a good question from Ravi. Question is, in other words, does it obey the throw exception in my custom function and stop processing? Yes. So in case the error occurs anywhere, it will basically stop the process of MapReduce and as if the Java code has exited, as if your mapper has exited. Okay. All right. Now there's a question from Naveen. A question is, if input is a map or bag, how to pass it as input to the UDF, and how to process map slash bag in in HDF. Okay. So generally, the good news is that here the classes like if you have a look at it here, so I'll just show you some things. What was that map you were talking about? Tuple and bag, not bag. Yeah, data bag. Okay, I'll just show you some things. All right, all right. Let me have a look at it exactly. So yeah. So the question here is, how do we handle in case the input type is bag or map? Okay. So generally you could here, I think you could extend it in a way. You could extend it in a way that you can define the eval function such that it accepts the bag. Okay. So I thought that the bag extends the tuple, but it doesn't seem so. So yep. All right. I need to look it up. All right. So yes, I need to look it up. All right. Let me just move it to the to-do list. All right, Naveen. Okay. So see, this question is, what does register do? What does register do? There are interesting aspects of register here. So register is registering our whole jar with pig, meaning that when we execute something, whatever jar we had, it will be sent to all the nodes, right? Because this function which we are using, the function which we are using here in generate has to be executed on all the records, and thus in all the mappers, not only on your current node. Therefore, this register pig UDF makes sure that your jar is taken to all the nodes, and then from that and from that the class is also picked. Okay. So registering is like saying, here is my jar, take it to all the nodes, and also when somebody is calling the function, look up in this file as well. That's what it says. It understands the moment you say register, it will go through the list of what is there inside it, and then build a kind of a class path. And when somebody says my udf.upper, it looks up in big udf.jar as well. All right. So that was all right. Yeah. Now, sometimes you don't have luxury to create your Java code. Sometimes you're dealing with the legacy code. Okay? In the legacy code, let's imagine that there is some old Perl file which contains some logic which is not yet converted into Java. You can stream data through that file, as in the way I displayed you the sort command, awk command. They do nothing but streaming data through them, right? Data goes streaming through these commands, say sort command, awk command, sed command. So the data goes through sed. SED, I mean, the word streaming started with the command called SED. SED stands for stream editor. Okay, so in the similar spread, you could pass each of the tuple of a bag. Divs is a dataset or a bag. We want to pass each of the tuple of this bag through this. Okay. Okay. And yeah. So all you need to do is say stream divs through hidiv.pl as this. As means whatever is the output of hidiv.pl, please consider it as this. Okay, and that's what will be the data type of hidivs. Okay, so the way we say load this as, similarly stream divs through this, and whatever is the result, consider it as this format, which means hidiv.pl supposed to give the data in tab separated format. Okay, next is sometimes this hidiv.pl may not be available on all the nodes. In those cases, we can define upfront like this, or sometimes your hidiv.pl may need custom arguments. Okay, for example, we might want to say hidiv.pl minus rxyz. Okay, and hidiv.pl is not existing on all the nodes, so you have to first copy it. So instead of you copying by yourself, you let pig do it, you let Hadoop do it. The way we said minus minus files, similarly we say this. We say define hd equals to this function, and before doing that, please ship it to all the nodes. Okay, and then you can utilize this as a function. You can see that stream divs through hd, right? And in that case, we are talking about this hd. All right. Now, please note that this code is a backcode. Okay, the purpose of putting it a backcode is so that while here, if you look at it, if you had to put double quotes here, something of this sort, okay, you could put that, or single quote or double quote or whatever. Therefore, the purpose of putting backcode is so that inside it you can have single quote or double quote, whatever you want. All right, so that was streaming through the data, streaming through the legacy code. Okay, Siddhar's question is, where are we compiling pig UDF to export HR? So by default, if you look at my project in here, the project is being compiled automatically. Okay, we are letting Eclipse do that for us. All right, we are letting Eclipse do that for us, and we are letting Eclipse to bundle the compiled ones. Ideally, you don't do this in larger projects. You use Ant or you use Maven to build such kind of artifacts instead of Eclipse, because Eclipse requires manual intervention. All right, let's take a break of 10 minutes and come back at back by back by 10:15 p.m. IST. All right, so should we start now? Yeah. All right. So, all right. So, in case you want to do the same thing what I did just now, you can basically download this project, import it in your Eclipse. Okay. All it does is basically it uh, creates a project. Along with that, it brings these libraries which you will have to fix. Okay. Here you can see that there is a pig.jar library that is required here for compiling. Sounds good to you? Sridhar is saying, I tried to download Eclipse, but it is giving error. Okay. So what kind of error are you getting while downloading Eclipse? So generally, downloading Eclipse is very straightforward. Okay. So you basically can download this Java EE version or Java development version. Okay. Either of the one. Either this one or you could say download. Under download, yeah, you have this Java for developers. You just select the one which is there by default and download. Okay, that should be good enough for you. Okay, all right, moving ahead. All right, so sometimes it is, sometimes you will notice that there are a lot of functions which are not there in Pig by default, and now those are very common functions. For example, CSV parser. Okay, for example, CSV parser or CSV Excel parser. Okay, so all you need to do in those cases is you can download something called piggy bank. And what is a piggy bank? It's a library of functions from different people, from other people. It's an open source library of function from other people. Okay, these are the functions which people keep on contributing. All you need to do is download this. Okay, and all right. So you can basically create a directory for pig source, okay, and then check out the code. Basically, you have to check out the code, compile it by using ant, and then you will have piggybank.jar. Okay, so I'm not sure if the piggybank jar is available. Let me fix it. It was there in the older work. We may have to get it from there. All right. So I'll have to get it for you. I had compiled it earlier and kept it in data folder. I'll do it again sometime. Did we do it here? We say Hadoop fs minus ls data slash pick. Oh, it is there. Yeah, it is there. Okay. So, yep. So you can download this piggy bank here. Piggy bank contains the lot of libraries contributed by many people. To go through what is there in the piggy bank, go to this URL and it will be useful. The exercises which we talk about in this, in case of pig, you will realize that if the data contains comma, using pig storage with comma as separator does not help. Therefore, you will have to utilize this particular storage, okay? This particular storage after registering the piggy bank. Sounds good to everyone? All right. Now, a few advanced operations in case of pig. So sometimes you have to use the map reduce for the values. If you have lot of values and let's say your data set contains lot of values for a group. In those cases, inside itself, you may want to use the same uh, standard MapReduce. Okay. In those cases, the for each nested is quite useful. Let's take this case for instance. You have this great list of cities and the people. You want to what you want to do is you want to find the count of distinct name in each city. Okay, you want to count you want to find the count of distinct name in each city. For example, in Bangalore, there is Sandeep, and Vivek. Therefore, there are only two names, unique names, while in case of New York, it's only one, which is John. So if you have to do this kind of work, what will you do? One way would be that we do a group by over the city, and all these values are combined together, and then we go through this list and try to do the unique. What if there are many people inside Bangalore, right? There'll be many people inside Bangalore, so that group by after group by the list will be really really huge. Therefore, to solve those kind of problems, you use the for each nested. Okay, you have people equals to load people as city comma name, and then group equals to group people by the city. Okay, and then you say counts equals to for each group dname equals to distinct people dot name, and generate group comma count of dnames. Okay, so what exactly are we doing here? After we grouped people by the city, what we have done is we are saying for each group. For each group, when you put curly brackets, the value is available as a data set. Now, you can apply things like distinct on that data set, right? Because group contains two data set. This group is a kind of a bag of tuples where first name is group and second name is the second value in the tuple would be people, right? People and group. So if you remember our discussion earlier, when you group something, the definition of the data type is that it is after grouping the data, it create a big bag, and this bag is made up of tuples, and tuples have two columns. One is called group group, and second is your second column is the same name as the data set which was grouped, right? And when you say counts equals to for each group, you get those two data sets available here, right? People and group. Now you can apply all kind of operations here. Now you will be surprised to know that we can further inside a for each, we can put another for each, okay? Here, and then say generate inside it, and that's why it is called for each nested. Okay. Okay, Sridhar, could you send me the screenshot instead? Let me have a look. Probably Java is not installed on your machine. And also tell me which Windows are you using? You're using Windows? Are you using Linux or something else? All right. So this was related to something which some error in Eclipse. All right. So this is what we have right now here. Next is the interesting aspect of joins. So right now, what exactly are we talking? We are talking about various kinds of optimizations. One we talked about for each nested. Now the fragmented joins. Imagine there are two data sets. One is one contains billion entries, another contains 100 entries, and you want to join these two data sets. Now, if you're joining two data sets and one is really, really huge and other is very small, so small that you can load it in the memory, okay? Do you still want to go with the standard map reduce way? Or do you want to do this join on the map side? As in, while our map is going through record by record, it does the join by loading the second data set in the memory, right? So in those cases, all right, I think I missed your questions. Now a lot of questions have showed up. Vinay is saying, are tuples nested here? So this is what is causing the nesting. So nesting as in we can use for each within a for each. Okay. So when you put brackets here, you will get two data set. One is called people, other is called group. These are the two fields of the tuple, each tuple of grp bag. Okay. Okay. Sushant is asking for me to repeat this example. All right. Let me go through one step at a time. So what so we have people equals to load people as city and name. So people has one this and other this. Okay. Now now when we say group equals to group people by city. Now what will be the data type of this group? Anybody? So group bag is a bag, or you can say data set, okay, of of tuples, where and each tuple has got these columns. One column is group and other column is people. Right? You remember our group by definition? Right? So each tuple is these two columns, right? Now when you say for each group and put curly brackets inside this, all the fields of GRP are made available as if they are two different data sets. Okay, now you could do things like distinct, not distinct, say distinct on people, p equals to distinct people dot name. Okay, and then you could do other things as well. And similarly, you could as well in case of a group. Okay, if basically it opens up such that you can and say count equals to count p. Not like this. So we'll have to say generate. We say group, comma. We say count and p. Okay, you get my point? All right. So this is what a nested for each all about. All right. Good, good. So moving on to the example we were talking about. Say you have got two data sets, one containing billion entries, other containing small entries, and we are trying to join them. Imagine we want to translate the country name from the country code to IST code. Okay. Say for example, we want to convert IN into 91, US into +1, and CN equal to 86. Now, when you join these two data sets, all right. So when you join these two data sets, one way is that you go with the standard MapReduce. Other is if we had to do it manually, if we I had to do it manually, I will basically take this file, it's a second file, into the memory and do it on the map side itself. So the same thing can be done in Pig as well using using fragmented joins. And the way you do it, so you load the first data set, second data set, and then join both the data set, and whichever is small, mark that as using replicated. Okay, mark that data set as using replicated. Now that data set, whichever is marked as using replicated, will be loaded into the memory and will be applied, and the joins will happen. Okay, so this is a huge step in optimization. Okay, you can utilize this replicated join in order to make it really fast. Okay, although if you have to code, it will take a lot of time to change this strategy. Randhir, can you do SSH or use the VETI on H2 or H3 instead of trying to run on your desktop? Okay, I'm not sure what exactly has been configured. Okay, or you just send me the email separately so that I can help you debug. Sridhar is saying we can use lookup for this instead of join. That's right. This is what exactly it means when we are saying using replicated. Now if we say lookup, probably you mean the same thing, as in you load the data on into the memory and you look it up, right? Yes. Yes, Veena. A small data set is being replicated. We are marking that as using replicated because Pig doesn't know the data. Instead, you are explicitly saying that this is smaller data. All right. Now, sometimes you get skewed data. Okay. Skewed data means when you are grouping values or joining values, say you're joining users and cities. Some city, there are millions of people, and some cities have few people, right? So the skewness is basically huge. If in case for some keys the values are millions, and for some keys there are values are some or only few. In those cases, there is a huge skewness. In when Pig encounters skewed data, there are very high chances of it crashing. Okay, it may not, it may overload your MapReduce, unnecessarily, because imagine to there if there are million values in case of few keys in MapReduce, the reducer will get overloaded, right? In those cases, you could simply mark the city, mark the join as skewed. Okay, if you are joining two data set where for some keys, for some cities, there are too many values. For some city, there are few values. You mark such kind of join as skewed, and Pig will take care of it. Pig will assume that the values, the number of rows for each ID are very high, and accordingly will take a step. Okay, we'll probably combine more columns in ID and then solve the problem. Okay, so Sridhar is asking for the link of the project. I'm just pasting the link to all of the people. All right. So skew data is good, and sometimes if you know for sure that your data is already sorted and you're joining on the same column on which the data is already sorted, then you can explicitly mark that, hey, my data is sorted. Don't try to sort it again. While joining the two data set, do not try to sort it. My data is already sorted by the same columns. And that's a very important step. That's a very important step for Hadoop. Okay, so this will actually improve the performance. Okay, so a quick question to all of you. Question is related to general computing. If sorting a data set takes x seconds, how much time how much time would it take to sort the sorted data? Yeah, anybody? Very small as compared to x, very high as compared to x, similar to x. Yeah, correct. Thank you, Ravi. Thank you, Ganpati. Thank you, Sridhar. Yes, it will be C. Very similar. Okay, slightly less. I mean, it will be similar, not even less, actually. Okay, so sorting the sorted data is a very interesting challenge, and sometimes it can actually take more time. If you're using binary search, okay, then sorting the okay, then it takes more time. But if you are using bubble sort, it takes very less time. Okay, but nobody in the industry uses bubble sort actually. Okay, bubble sort is just for academic reasons, and it's just a theoretical algorithm. Nobody uses bubble sort actually in practical. Okay, bubble sort is like keep swapping the every two columns unless there is nothing left to sort. Okay, therefore, in the most of the merge sort or quick sort, in both the cases, sorting the sorted data takes approximately same time. Okay, Susant, your question is related to why nobody uses bubble sort, or why does sort takes less time? Okay, so bubble sort is an algorithm which depend on the fact that it keeps checking all the time. Is it sorted? Is it sorted? Is it sorted? Okay. Therefore, in case it's given a sorted data in the single shot, it will figure out that oh, it's already sorted. Therefore, bubble sort will take a very small time to sort the sorted data, but it will take a very high time to sort the unsorted data. Therefore, bubble sort is generally not used. All right. So that's why since none of the algorithm try to predict that the data is sorted or not. If they try to predict it, they'll become considerably slower. Therefore, it's wise to mention that my data is already sorted if you know it. Okay? If you know that this data was, actually, it has saved my life a couple of times to know about data. Okay? So, I had already talked about a problem when I was about to launch my recommender. We realized that nobody in organization is allowed a map task size beyond 200 MB. Okay, so map task cannot consume more than 200 MB, and so was the launcher. Launcher was also not supposed to consume more than 200 MB. Launcher is the machine from which you are launching your map reduce. Okay, from where you're doing a lot of, maybe sometimes you can do a lot of offline things. So when I realized that when Mahout is running, giving the recommendation, it actually gives the recommendation ordered by the product ID, user ID. Therefore, I don't need to sort it. So I utilize that information in in order to merge the data without again sorting. All right. So knowing about data is always very helpful. Knowing about data is always very helpful. Okay. And knowing about data is something which you can do differently from what machine could do. All right. Now, now sometimes you want to join and group based on the same column. In those cases, you use co-group. So basically, if you know that your data is spread into two files, and you want to join the two data sets as well as group it, then it's I mean it's better to use co-group, because co-group again will utilize the same phenomena. Because if you first join the two data set, then it will anyway sort the data based on the same column, right? And then when you they say group by, it will again sort the data. Therefore, there are two sorts. So it's generally advisable to use co-group if you foresee this kind of circumstances. All right. So you can see that here we are first joining it. We are grouping by cat, which means Alice cat and Adam cat. There are two data sets after grouping, and then we are joining it. So first we are grouping both the data set, and then we are joining them. First grouping them and then joining them. So it's like we executed group on both individually, and then we did the join with merge marked. Okay, if I have to do the same thing, I will first group both the data sets individually and then join them by saying merge, because my data will already be sorted because it has already gone through the map reduce phase. All right. So Sometimes you have to concatenate the two data set, okay, head to tail. In those cases, you use union. In those cases, you use union. Union means all the records of A and B, if your union is called on A and B, will be concatenated head to tail, as in first all the records of A will come, then all the records of B will come. All right, so I'll show you this. Now, sometimes you know that while putting these records one below the another, make sure to fit in the right column. If they have columns, similar columns, or same set of columns, you can fit the right column below one. Okay, and how do you do that? I think the next screen will clear it. Let's say you have data sets A and B. You are simply saying union. Okay, so what would happen is all the records of B or A, so it'll become B. What is that? Yeah, B2, B12 and A12. You can see B12, A12, and B22 and B21. You can see those records, and then A21, whatever. So there is no predictability in what order they will come. Now, if you say union schema is quite interesting. Union on schema forces the schema on top of these data sets. So what columns does A have? X and Y. B has Z and X. So when you try to enforce schema while unioning, it'll have three columns: X, Y, and Z. X, Y, and Z. Now, so when we are concatenating B and then A, so B does not have Y column, so the Y column will be left. Similarly, A doesn't have Z column, so Z column will be left. So you will get this kind of data set. And in reality, this is how it would look like. Look like B12, comma, blank, then A11, B22, comma, blank, B21, and so on. So this way, you can enforce schema. All right. This is very useful when you have two data sets and you're trying to do these two data, concatenate these two data sets, and you're not sure about their order in which various columns have appeared. You want to make sure the columns are coupled together. Okay. All right. So generally, when you have records, historical records, which keep on getting saved as CSV, for example, and you want to, at later point of time, you want to union it in order to do some kind of grouping or any other analysis, you're trying to enforce a schema on top of those records. Then you use union or union on schema. Okay. So I hope union, schema, and union is clear. Yeah. Veena, do you need an example still? All right, good. So, anybody, is it clear to everyone? So, what will be the result of saying C equals to C equals to join A and A comma B? Anybody, quickly? All right. So what will be the result? Anybody? Veena, Pavan, Sushant, Ravi, Ganpati, Randhir. Just some data set A and B. Yes, there is no common field specified, and therefore no, it will basically give an error because that's not something the syntax of join does not allow that. Now, if you have to do a cross product of A and B, as in all record of A joined with all record of B. If A has n record and B has m record, the total number of records you want is n into m. Then you go for cross products. Cross product is basically multiplying one record with all. Okay? Okay. So you use Cartesian for Cartesian product, you don't use join. Instead, you use another syntax called cross. Okay. So some of you must be wondering that how will this be implemented in MapReduce? Again, I'll point you to the same example. The matrix multiplication should give you the matrix multiplication example should give you a decent amount of background on how the cross product is done. Okay, take a look at my matrix multiplication using Python. So cross may not be, this cross product will not be done on the mapper side. It will also be done on the reducer side. Okay. And therefore the parallel will make sense. All right. Now, sometimes since pig is generally used for analytics or generally used for generating reports. Okay. So and in reports, you want to execute same script with the different arguments. Say today one report was running. One report was running at 10 a.m. with 10 a.m. as the argument. Then we want to run it again with 5 p.m. as the argument. As in, we want to generate the data for last 1 hour. Okay, so we want to just change the time for which we want to execute it. So for doing such kind of changes, it's not a great idea to modify the file. Why it's not great idea? Because such kind of executions happen through programs, and editing a file through a program is not a great idea. It's a very difficult thing. Okay, therefore it's always advisable to build reporting engine or reporting system which can expect arguments, which can accept arguments. And so pig also tries to fulfill that. So has pig takes the argument from the command line. Okay, so if you have, let's say you have daily.pig, one file called daily.pig, which contains date, I mean, which contains a variable called $date. You can run this by specifying this particular parameter on the command line argument. You could say, okay, you could say things like that. All right. So you could say pig minus p is for parameter, and date equals this. And then you could run daily.pig. And this, whatever you are giving the value to this, will be filled here. Okay. So this way you can provide the argument. Sometimes these number of arguments keep on increasing. So you could put these arguments in another file and then use pig minus param file and execute it. All right. Now, Pig also provides splits. Although splits are something you can emulate by yourself by putting filter and by putting other mains, but splits are very, very powerful and useful. If you have a big data set and you want to create multiple data sets out of it, you could use a split. You could say, let's say weblogs equals to, I mean wlogs instead for weblogs equals to load weblogs as page ID, URL, and timestamp. Now, out of these wlogs, you have three different kind of processing which need to be done. One, for all those records which are less than 4th April 2011. Then second kind of processing is required for the records which are between between 1st of April and 3rd of April. Okay, 1st of April and 3rd of April. Then there are some other split for which you want to run a separate processing, which is between 31st March to 2nd April. Okay, so this log could be split into multiple data set in this fashion. Okay, now you can notice clearly that one record could go to multiple legs, as in, imagine all the data of all the records of 3rd April. 3rd April will go to April 3, as well as no, April, all the records of April 1, April 2, April 2 will go to APR 02 as well as APR 03, right? And similarly, for the April 1, the records will go to April 01 as well as APR 03. So you can see that one single record could go to multiple legs, and also some records could be dropped out. So it's not really split. It's more like what do you call, switch case. Okay, more like fork. So Vina's question is matrix multiplication easier to do in MapReduce than Pig? Kind of, yes. I found it easier because to do the same thing in Pig might have taken a long, long time. But now I feel that by using cross products, you could make it easier. Cross products could make it easier, but I'm not sure. Once I start try to do it, then the complications will arise. But I feel that the things which are not related to kind of tuple algebra way, where you have data sets and all, pig is not pig is not the right thing to do. If you are doing mathematical operations, large scale, say, probably matrix multiplication is a good example, or say you are doing some kind of Fourier transformation or some kind of that, then pig may not be very useful. You might have to keep on creating the UDFs. Yes, all the records go to April 0 through 3. Okay, so yes. Now, there are few things you should note in the previous example. In the previous example, the logic which looked like we have done a lot of steps, actually everything will finish in a single map. There'll be ifs and elses inside the maps itself. So there'll be not many different map phases. There'll be single map phase doing the doing the if else inside it. That's what that's what is that's what is split about. And also it so there are a lot of Pig tries to do a lot of non-linear execution, as well as Pig tries to group multiple things into one and filter into one. Okay, so when you are running a Pig script, the moment you say dump, lot of things happen in the background. It tries to combine all the groups into one, meaning all the reduce should happen in a single shot, and filters into one, meaning all the mappers, instead of being separate map phases, they all are combined as a single map phase. Okay, so it does a lot of optimization. Also, nonlinear execution means things will not be executed in the top to down fashion. Okay, top to bottom fashion, the way our C program, Python program, or shell scripts are executed. Okay, the pigs script do not get executed that way. Pigs script get executed based on the demand. What is it that you have called dump on? If you call dump on or store on a particular data set, all the data set on which this particular data set depends get saved to the storage. All right. All right, so next is Pig Latin versus SQL. That's a big discussion. So I would like to keep it short. In case of Pig Latin, user describe exactly how to process the input data. In SQL, user allows you basically, so in very simple words, SQL generally finishes as a single executable query. So every query, as soon as you run that statement, the whole thing runs right away. In case of Pig, you basically write down steps, do this, do this, do this, and then say now execute everything. Okay, so in case of Pig Latin, user describe exactly how to process the input data, and in SQL, users ask what questions they want answered. It's a long series of data operation in the Pig Latin, while SQL is all about answering a single question. In case of Pig Latin has been designed bottom up for distributed computing, as well as to handle unstructured, semi-structured data, while SQL is designed for RDBMS. Therefore, the optimizations such as fragmented join or merge joins and replicated joins are not something possible, or skewed joins are not possible using SQL. And the same argument what we are having right now, Pig Latin versus SQL, also holds true when we have discussion between Pig Latin versus Hive. Okay, okay. Now, Pig Latin can be used when schema is unknown, incomplete, inconsistent. In case of SQL, it wants the whole data to be well formatted before consuming. All right. You can have a look at the Pig's documentation here. And if you want to do a custom load functions, you can have a look here. Okay, that will help you understanding the custom load functions. All right, have a look at the exercises. Please try to finish the exercises. These are the exercises, subjective quiz. Please finish those. All right, now let's continue with our discussion on Hive. All right. Any other questions before we start with our Hive discussion? Okay, Sushant's question is, can we count number of files in Hadoop? You mean in a folder? Okay, so generally whenever you are saying things like this, one way is to just pass it to wc minus l. Okay, can see. Is that what you need? Okay, I mean to say, I'm reading Sushant's question. I mean to say, if we can save intermediate data into structured data for further analysis. Yes, we can do that. Okay, all right. So that was our discussion on pig. All right. So good. Also, lot of data visualization or data presentation happen using the traditional tools. Okay. The only role of Hadoop in those cases is to convert humongous data into small. Okay, by using MapReduce. You will write MapReduce in order to bring down the big data set into small. Either MapReduce or Piglatin. You will use that, or maybe Hive, either of them. All right. So let's start with our discussion on Hive. All right. So we studied Piglatin. We studied MapReduce. Okay, and we found that MapReduce was even difficult for developers, and there is a lot of repetitive logic such as joins. Okay, so Hadoop is great, and MapReduce is great, and Pig is great, but there are many users, existing users, who are expert at SQL, as well as they have a lot of their infrastructure in SQL. How can you move? How can you move everybody into MapReduce or Piglet in one fine day? Right? You can't. You can't. Even if people learn these new tools, moving the existing infrastructure is almost 2 decades work. It'll take like 20 years to translate their last 40 years work. Therefore, people realize that instead of doing that, let's get adjusted with SQL, and that's where they created Hive. So What Hive does is the way Pig Latin was translating. While Pig was translating Pig Latin into MapReduce, Hive translates your SQL into MapReduce. So you write your logic in terms of SQL, and it translates it into MapReduce and get your work done. All right? Is everybody on the same page? All right. So this Hive discussion is going to be very important because our project depends on it. Okay, our project depends on it. If you want to do it other way, then you can do it other way. But the default way, which I would give you an example, would be using Hive. Okay, so pay good attention so that you will have good amount of flexibility. Specifically, if you are from SQL background, then you will find Hive really, really useful. You don't have to worry about doing something in SQL or doing something in Pig or doing something in MapReduce. You can get most of the stuff done using Hive. Okay. So Vina's question is, so can all SQL commands work in Hive as such? Most of them can, and some of them cannot, and therefore we are having today's discussion. Still, even if you have a legacy code written in SQL, you want to run the same thing in in Hive, it will not be possible. There'll be minor tweaks here and there that need to be done, or sometimes there'll be a major change. All right, and that's why we are learning Hive. All right. So what exactly is the value proposition of Hive? It's mostly suited for data warehouses. It's basically useful when you are trying to analyze relatively static data, when fast response is not required. When fast response is not required, okay? So please note this statement like fast response not required. Why? Because since it converts the SQL query into MapReduce, there is a slight delay. Also, since MapReduce itself has got the boot up time and it's a batch oriented behavior, it takes long time to get Hive query executed. If you are expecting your query to finish in milliseconds, then don't expect it. Okay, because Hive will run using MapReduce, and each MapReduce job runs something like 5 to 10 seconds minimum. Okay, even the hello world example will run in 5 to 10 seconds. Okay, so Hive makes it easier to port existing projects, provides SQL dialect called HiveQL, maintains the metadata. So when we were studying pig, did you notice that if your you exit the pig command, all the data sets you had created using load and filter and whatnot, all of those are gone, right? But in case of Hive, since in the databases, if you create a table, it is persistent. It is there even when you connect again. Therefore, Hive had to store the data somewhere, and that is metastore. So the definition of tables is stored in metastore. We'll be creating tables over data. It allows querying HDFS files and HBase. Okay. Please note the relatively static data. Just like Pig, Hive also does not allow modifying data. It is only for querying, or at most you can create the whole table from a given data. It does not provide record level update, insert, or delete, but it can generate new tables. It is not suitable for OLTP, online transaction processing, because online transaction processing requires extremely fast response, which it cannot provide. Why? Because queries have higher latency, and Hadoop being batch oriented, there is a startup overhead. Because we have been executing Hadoop job for quite some time, we must have seen that the general behavior of Hadoop is not to hurry, instead be more reliable, get the work done, whether one machine, two machine, three machine, or whatever, but get the work done. So the behavior of Hadoop is more about reliability and humongous data rather than getting things instantaneously in milliseconds. All right. This meta store, as I told you, the meta store is stored in MySQL. The meta store is in MySQL. All right. This is great. Hive is great. When you have relatively static, huge data set and you want to keep it, mine it, and it's being maintained. And this is like general architecture of how does the general architecture of Hive. Okay. So as you can see that although this architecture is a little older, but don't worry, it's the same thing. So this is Hive. This box from here to there is Hive. Hive has got the basic component called driver. Driver is the one who takes the SQL, compiles it, optimizes it, and then runs the MapReduce on Hadoop. Okay. So this driver also communicates with Metastore. Metastore contains the definition of tables. Metastore is nothing but MySQL database. Metastore is a very thin layer who talks to this database. Tomorrow, if you want to replace MySQL with somebody, you can simply change those settings in the Metastore settings, and then Metastore will be written in that database instead of MySQL. Right now, we are using MySQL. You can also use Postgres or something else. Now, please note that this Metastore will be on only single machine. That means if that machine goes down, then Hive may not be able to work. Okay, that is the only downside of Hive. All right. So Sridhar's question is, if it's not fast, then we are losing one of the requirements to move to Hadoop. No, actually, if Hadoop, as in generally Hadoop batch processes are not really fast. Okay. All right. Let me describe this diagram. So the core component of Hive is something called driver. Driver talks to our Hadoop, okay, and gets the queries done. Okay, driver compiles, optimizes, and executes the Hive query language. Now it talks to Metastore, as well as sometimes driver directly talks to DFS. Specifically, if you are not using any where clause, you are just saying select star from my table. In those cases, it doesn't have to go through the full MapReduce cycle. Instead, it can directly talk to file system and print the data. Okay. Now on top of this driver and Metastore is the layer of services. The one service is Thrift server. Thrift server is basically Thrift is a service oriented architecture component. Thrift is a server using which you can create your own service for and have the client developed in almost all languages. If today you are launching your service, okay, service as in to be used by millions of people, in those cases, having thrift server as a great idea. Although it's a binary one, it is not a based interface, but it is pretty fast and it's actually very good where state has to be maintained in the protocol, unlike the HTTP. Okay, so thrift was contributed by Twitter, and it still stays as one of the prominent server in the open source ecosystem. All right, so you have thrift server, you have Hive web interface. Hive web interface is the one using uh, using which you can talk to Hive and get the work done from the web using Hue and Kubo, Comma Sphere and all. Then you have CLI as in command line interface for Hive. That's the one which we'll be using. On top of Thrift server, you will have various kinds of JDBC, ODBC drivers talking to Thrift server. So Hive has something called Hive server, which is basically a JDBC server, and all the services who say you are the project you will be doing, you will be talking to this JDBC server, you'll be talking to this JDBC server, and through which you'll be talking to thrift server, and then you will be talking to the driver. Okay, so in the project, since you will be querying the data from your Excel sheet onto our server, then you will be talking to this JDBC server. All right. Yes, Randhir is right. Metastore does not store the data. It is just storing the definition of tables, right? All right. Quickly, you can have a look at this is a complex SQL query to do the word count. Okay. What it does is you look it from here, from inside out. So first of all, we explored the data. So first of all, we loaded this particular HDFS file. Okay, we loaded this particular HDFS file into a table called docs. It created this table called docs. Okay, let's try to see if I can make it run. All right, it says that we are requesting 2048 memory while the max memory is 1024. Let me check it because we were just tuning our cluster and I think we have reduced the memory size. So Veena's question is Hive just for structured data? Yes, in a way, Hive is good for churning the structured data. But sometimes you can actually get things done via Hive. For example, here what we're trying to do. First, we are loading this big text file from HDFS into this table. And then we are creating one word per column, per row. So there'll be a single column and there'll be one word in it. That's what we are doing by split and then explode. Just like we did earlier by splitting and then flattening. In case of pig, here we are saying split and explode. And once we are done with that, we do a group by and then we generate the count and this. And after that, we basically count how many times it has occurred. That's it. Okay. So that's about a quick look at how does it look like. And once it is done, we are storing it in word counts, and then we can have a look at the word counts. All right. So you can, this is not, so here, I think we should just say, okay, use CloudX Lab. Okay. So yeah. So right now it's not, it doesn't seem to work. Maybe I can change it. All right. So we'll do that later. Now, yeah. All right. So this is how either you can call Hive like this. In this case, it will start the prompt, or if you just want to execute a single Hive query, then you can simply say Hive minus E and then the query. Or if you have written the your whole SQL into a file, then you can say Hive minus F, that file name. Okay, so the same way as Pig, I think probably every tool which has client server architecture or every tool which interfaces with the developer or the users has all three modes in today's time: the command prompt way, the executing a single query, and third one is executing the full list of queries. Okay, quickest, the easiest table which we could create is create table x a int. Okay, and so this will create a table called x with a column called a, which is of the data type int, and then we can select from this table and drop this table. That's all. That will be the probably the simplest way of querying the data. All right. Now a little bit about the prompt called Hive. Okay. So the way you were executing HDFS commands, you could also execute HDFS command from here, from Hive prompt, dfs minus ls slash. So you could use dfs and then say minus ls minus make directory mkdir minus cp and whatnot. You can do from the Hive prompt as well. Okay. Also, you can load a Hive script from within the command prompt using source. Okay, all the commands start with double dash. You can also set the environment variables which you can use inside your Hive queries. Okay, sometimes you want to execute the shell commands by putting exclamation. Okay, by putting exclamation you could execute the shell commands. All right, there's a question from Randhir. Question is, once you create a table for specific file, so every time you query, will it expect that file to exist in HDFS? Yes. Very good question. Yes. If it is not, the file has been deleted, it will say that there is no record in the table. Okay. So a table in Hive is nothing but a representation of the, is basically a window into the file. Okay. In case the file gets deleted, there will be no records in the table. In case you add manually some of the records into this file, then this table will, when you say select start from this table, automatically those records will display. And sometimes you corrupt the file, you overwrite over it something else which is not fitting into the columns of the table for which the file was created earlier. In those cases, it will give error saying it cannot parse the data. Now, Vina's question is here. I think it's a very important question. Is there an advantage of using pig over hive? Yes, in the sense that it is slightly more controllable. Okay. And the other advantage I find is pig is far more simpler than the hive. I like to break down my queries into steps and then execute them. All right. So that's pretty much for today. We'll see you tomorrow. Have a great day. Bye bye. All right.